This is a demonstration of my articulated circuit board project, which I also refer to as Bendy boards, because it's an assembly of PCBs linked together in such a way that they maintain electrical contact all along the length of the boards, while you can still bend the boards in the assembly relative to one another to create all sorts of fun motion and effects. So the way this project works is there's a control board at the head of the chain, controlled by an ATtiny 1614 chip, and underneath it's powered by 2 coin cell batteries. There's a power switch on top, a push button to allow selecting different LED patterns. And each top level circuit board has 3 NeoPixel 2020 LEDs along with 3 decoupling capacitors, so you can display different colored patterns along the boards in the chain. Each link connects to the next one in the chain with a press-in snap connector that you see here. It's pretty tiny, but it has 10 pins, and we only need to actually pass power signal and ground for the NeoPixels. So there's some redundancy in the pins, and as you may be able to see here, I actually bridged 2 of the pins on this connector when soldering, but they're both voltage pins, so it doesn't actually matter. So each link in the chain connects through these snap connectors to the next one. And so if I turn this on, start a pattern running, and then I carefully snap it to the next one, the power signal and ground pass to the next link in the chain, and I can rotate each link in the chain around a pivot between the 2 layers of that link, which we'll take a look at next. Now, these snap connectors aren't incredibly robust, so after you snap them together, I'll fasten them in place with an M2 screw and nut to hold the link together without putting too much stress on the snap connector. And to take a closer look at a link, you can see each link is comprised of a top layer PCB containing 3 2020 sized NeoPixels along with 3 decoupling capacitors, and on the underside, along with that snap connector to connect it to the previous link in the chain, are 3 circular ring-shaped pads that make contact with pressure connectors in the PCB that forms the bottom half of the link. So the bottom side of the pressure connector PCB is empty, but when placed together so that they're centered around the holes in the middle of the boards, the pressure connectors make contact with the rings in the top layer, allowing the signal, voltage, and ground electronic signals to pass from one board to the other, no matter what the orientation of the top and the bottom boards are relative to the other. Now, these pressure connectors are a little fragile, so there's a buffer layer of clear acrylic sitting between the two circuit boards. This acrylic is 1/16 of an inch or 1.6 millimeters high, and the working height of these spring contacts is about 1.7 millimeters. So that works pretty well in preventing the spring contacts from getting crushed when you press the 2 circuit boards together, but also allowing them to make good contact. And you want, for this assembly to work, each link needs to be held securely together without allowing for too much wiggling. Now, each ring makes a connection with 2 of the pressure contacts here, so that does allow, if there's a little bit of wobble, the signal to still travel through the other connector, but you still don't want too much wobble. And the way to keep these boards together is to use a plastic snap rivet, which I've got right here, that's just the right length when popped into place to hold these boards securely together. And this one is an M3 rivet that holds a total thickness of about 6 millimeters together. These boards are 5.4 millimeters when stacked all in all. So you put the rivet through the top level board, pass it through the buffer layer and down through the bottom board, hold them together and push them securely, hopefully, into place until it snaps, and then you have a good connection that still allows the boards to pivot. And then you can place the entire assembly together by connecting these snap connectors to connect the links and securing them with nuts and bolts, like so. So that's how the project works. And it's been a fun project to design. So one more here.